Hi guys, today we are going to take a look at section 2.4, which are called the library of functions. Today we are going to graph the library of functions using t-charts for a couple, and then I'll just describe some of the other ones to you. And then we're also going to look at what are called piecewise defined functions. So the first function that I want to take a look at is the square root function. So f of x equals the square root of x. So the first thing, to graph it, we want to come up with some smart numbers to plug in. So like 0 is a good number to take a square root of, 1 is a good number, and so is 4. Okay, so those are the numbers I'm going to plug into the function. When you plug in a 0, you get 0. When you plug in a 1, you're going to get 1. And when you take the square root of 4, you're going to get 2. So those are now ordered pairs. Okay, so the point 0, 0 is on our graph. Okay, so that's 0, 0. The point 1, 1, over 1, up 1. The point 4, 2, so 1, 2, 3, 4, up 2. And then you would have points like 9, 3, or 16, 4 that are going to go off the graph. So these 3 points we're going to use, and that's what the square root function looks like. Okay, now down here in this box I have some properties of the square root function. These are not things for you to memorize. This is just information that you should be able to look at that graph and tell. So like the domain and the range are the set of non-negative real numbers. So in other words, the domain is everything from 0 to infinity, but so is the range. The range would be everything from 0 to infinity. Okay, the x and the y intercepts are 0, so the graph goes through the origin. This is not an even nor an odd function. There's no symmetry going on. This is increasing. Okay, it's always increasing, and there would be a absolute minimum value at 0. This is not a local minimum, but there is a low point, like an absolute low point, since the graph stops right there. Okay, so those are just things you could pick up. Once you graphed it, you should be able to answer those questions, because those are the things we've been talking about. The one on the bottom, this is a cube root function, so this one's going to look a little different. First off, the numbers that you plug in. Okay, so numbers you want to take the cube root of would be, so 0, 1, I can take the cube root of 1, but then the next perfect cube is 8. That's the numbers I want to take the cube root of. I can also take the cube root of negatives. I couldn't take the square root of negatives, but you can take the cube root of negative 1 and the cube root of negative 8. Okay, so the cube root of 0 is 0, cube root of 1 is 1. Now, the cube root of 8, 2 times 2 times 2 is 8. So the cube root of 8 is 2. Since 2 cubed is 8, the cube root of 8 is 2. Okay, with negatives, the cube root of negative 1 is negative 1, and the cube root of negative 8 would be negative 2. So these are all ordered pairs that are going to be on this graph. So I could graph 0, 0. I like to start at the origin. I could graph over 1, up 1. And then I could graph 8, 2. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. Okay, but also I could graph negative 1, negative 1, and negative 8. 1, 2, 3, 4, 5, 6, 7, 8, negative 2. So those are the points that are going to be on this graph. This graph goes up, kind of like the square root one does, but there's also this negative part where things are going that way. Okay, and that's what a cube root function looks like. Again, domain and range would be all real numbers, since this goes to negative infinity and in positive infinity. X and y intercepts would be 0. The graph is symmetric to the origin, so this is an odd function. If you flip that over, it's going to look the same. It is increasing from, like always, so from negative infinity to positive infinity. It's always slightly going up. And this does not have any kind of local minimum or local maximum value. Okay, so that's the graph of a cube root function. On page 2, I'm just going to walk you through some of the other, what the book calls the library of functions. So these are all graphs that you should just be, kind of familiar with. So like a constant function. So f of x equals some number. So this is like in algebra when they would say y equals 2. Okay, so for example, that's just a horizontal line that would go through 2. So f of x equals b is just a horizontal line that goes through some point b. The identity function, that is f of x equals x or y equals x. In other words, y is just whatever your x is. So you're going to have points like 1, 1, 2, 2, 20, 20, negative 10, negative 10. So whatever x is, y is the same. And you just get this diagonal line. It's like at a 45-degree angle that goes through the origin. The square function, you should be familiar with f of x equals x squared. It looks like this. It's a parabola. You have the point 0, 0. You also have over 1, up 1, left 1, up 1. Those are the points you're going to see on the square function. The cube function, this part looks very similar to the square function, but when you cube a negative, you get a negative. So when you cube negative 1, you get negative 1. When you cube negative 2, you're going to get negative 8. So you're going to get this shape that looks like this. Again, it's an odd function. I usually refer to this as an S curve. Those of you who drive are probably familiar with an S curve on a road to let you know what's going on, and that's what that kind of looks like to me. And then on the bottom, the square root and the cube root function, those are ones that we just graphed with T-charts. All of these graphs that I just showed you, you could graph using a T-chart if you weren't exactly sure what it looks like. Okay, third page. We've got what's called the reciprocal function. This is one you probably saw in Algebra 2, 1 over x. You cannot put a 0 into this. Okay, so this would have a domain that x cannot equal 0. But anything else you plug in, it gives you the reciprocal. So when you plug in a 1, you get 1, because 1 is its own reciprocal. But when you plug in a 2, you get 1 over 2. You get 1/2. When you plug in a 3, you get 1 over 3. But when you put fractions in, like 1/2, you get a 2. So you get this curve that goes this way. When you take the reciprocal of negatives, you get negatives. So you get these this curve that's over here. So again, this would be an odd function, because if you flip this upside down, it's going to look the same. And that's the reciprocal function. This is the absolute value function. Starts off, it kind of reminds you of a parabola, because you've got the point 0, 0, over 1, up 1, over 2, up 2, over 3, up 3, okay? But also, when you take the absolute value of negatives, you get positive answers. So the absolute value of negative 1 is 1, negative 2 is 2, so on and so forth. So you get this V shape, and that's what an absolute value function looks like, okay? So those are graphs that you should be very familiar with. Last thing we're going to talk about are what are called piecewise defined functions. Okay, now this one may take a little bit more time to get if you haven't seen these before. What this is a function that gets split into different values depending on what x's you are trying to plug into it. So that's what this over here is telling you. This says that when x is less than 0, so if you plug in, if your x value is negative, you are supposed to use this function. Okay, you ignore these two. Okay. When x is less than 0, you use this function. If I give you an x that is between 0 and 3, so including the 0 but not including 3, you use this function. This is just a constant. It just says if x is in here, then your y value is a 2. That's it. There's no math to do. This says that when x is greater than or equal to 3, so if I give you a 3 or a 4 or a 5 or a 6, we're going to use this function. Okay? So you use the function depending on what x I give you. So that's your first job. So over here, we're going to find these values. So look at the first one. What is f of negative 2? Since my input is a negative 2, and negative 2 falls in this range right here, it is a number less than 0, we're going to use this function. We're going to take the absolute value of negative 2, and we're going to get 2. That's it. That's all you have to do on that. Okay, look at the next one. The next one says negative 1. Well, again, negative 1. So what is f of negative 1? we're going to come over here. -1 is less than 0, so we're going to use this function. We're going to take the absolute value of -1, and we're going to get 1. That's it. Now, I know you could do these steps in your head, but I'm writing them down for your notes. Okay, what would f of 0 be? Well, again, if you look at this, once we plug in a 0, you'll see 0 twice. But this one says x less than, this says 0 less than or equal to. So this is the one you use when x is equal to 0. Well, when x is 0, your function is just 2. That's it. F of 1. When f is 1, we're in this little interval right here. So when x is 1, we get a 2. When x is 2, you get a 2. When x is 3, you do not stay here. Okay, we're not in this interval anymore. This says less than 3. This one says x greater than or equal to 3. So now we're going to use this function right here. So we're going to plug in a 3. So 3 plus 1 squared. That's what we're going to do. Well, that's 4 squared, so that's 16. Okay, what do you get when you plug in a 4? Well, again, we're in this interval right here. And when I plug in a 4, we're going to get 4 plus 1, which is 5. 5 squared is 25. So that is what you get when you plug a 4 in. So with piecewise functions, the only thing you do is I'm going to give you an x value, an input. You need to look at these intervals, choose which interval your x is in, and then that's the function you use. You ignore the other ones. This is the only one in play. If I give you a -2, this is the only thing you're looking at. Okay? So those are piecewise defined functions. On the bottom, I have kind of a story problem that involves piecewise defined functions. Why don't you read that, pause the video, read this, and then see if you can find A, B, and C. Okay? Go ahead and pause the video now. All right, so here are the answers that you should have got for the bottom. Okay, so it had to do with an electric company and how they charge. If you use 300 kilowatts, then you are in this interval right here. You're between 0 and 400. So I plugged it into that, and I got 3241. Okay, if you use 400 kilowatts, again, you're still in this interval. Okay, because this says x less than or equal to. So this is the one we use when it's or equal to 400. So I plugged in the 400, and I got $40.68. And then the last one, I was 700 kilowatts, which is obviously greater than 400. So I used this function, and I got $59.30.